In this problem, we have h of s is equal to 50 over s plus 50. To convert this to Bode diagram, we need to convert all of our s's to a j omega. So s is equal to j omega, and then we can rewrite this. So we have h j omega, and this is equal to a 50 over our j omega plus 50. Now, from here, what we can do is we want to make this look like this. We basically want to have a 1 instead of our j omega out here. And then we need to write our k with the z1 and p1. So we don't have any z's because remember z's are 0 and that's in the numerator. We don't have anything in there. In our denominator though, we have this p1 which is 50. So in essence we're going to have 50 because this is our k, and then we're going to have 1, or not, this is not our k. This 50 out front is just a constant. So we're going to have our constant out front, and then we're going to have our z1 over p1. It's important not to get those confused. And then from here, we are just going to have a 1 in the numerator, and this is because we have no zeros. If we did have zeros, it'd probably be a little bit different, or it would be a little bit different. And then we have a 1, or sorry, we have a j omega out here, and then we have a 1 plus our j omega divided by our p1, which is 50. Now, just looking at this, we can see that our 50s right here are going to cancel out. And once they cancel out, we are going to have 1 divided by our j omega, and then we're going to have 1 plus j omega over 50. This is our new equation. Writing our Bode diagram, since we're doing it in one note, it's not going to be very exact, but we can do our best. So we're going to start at 0 here, and then we're going to start at 10 to the negative 1 here, 10 to the 0th here, 10 to the 1st, 10 squared, 10 cubed, 10 fourth, and so on and so forth. So this is our graph, and we know that it is a decibel by our omega. So we'll have omega in the x-axis, and then we know that also this is going by 20, 40, 60, and so on and so forth. And then we have our 90 degrees here, and then we'll just have like a negative 90 degrees here. And so this is our Bode diagram. And now we need to actually fill it in. We have two parts to this. We have this j omega, and we also have this 1 plus j omega over 50. So looking at the notes linked below the like button in the description, we can see on page 97 the summary of Bode straight line magnitude and phase plots. So for the first one, the 1 over j omega, this is really 1 over j omega with an n outside these parentheses. And so for the phase part, this is going to be a negative 90 degrees. So we're going to have this written out right here. And then obviously it has a slope of 0. We're going to look at this next part. It's going to be the exact same. It's going to be 1 plus j omega over 50 with the 1, of course, right here. And then this is being raised to the n power. Now, since the n is both 1s, this slope is just going by this 20. And we've explained before that if it's like a squared, it's going to go by 40, cubed, it's going to go by 60, and so on and so forth. So looking at the table, we're going to be doing the fifth one. And this, they look alike right here, so that's why we're doing it. And we're going from p over 10 to p times 10. We only have one p, and if we had multiple p's, we would basically just pull out a different color and do a different, or do the same scenario, just with the different values. And so we're going to be going from 5 to 500. And so we can write this out. We can say that, well, if this is 10 to the 0, this is 1. So we're going to have a 5 right here. And then 10 squared is 100, so we're going to have a 500 here. And then we know that everything before this is just 0. And then everything after this is a slope of negative 45 degrees. So we can write negative 45 here. And then after this, we're going to hit our slope of negative 90 degrees. And I should have probably drawn this a little bit better. This negative 90 degrees should be in this part right here. So it would actually look something a little bit more like this. So our graph is a little bit, the slope is not going to be very steep for it. So it's going to be like something like this. And then once it reaches here, this part, it's going to be a negative 90 degrees because this is our negative 90 degrees right here. And then this is still negative 45 degrees. And so our graph, the slope change is important to note, and it happens right here. It also happens right here. And so we can use this in finding our phase inflection frequencies because we need to write out the Bode diagram. The Bode diagram, we're looking at these 2 degrees, and I'm actually going to do it in this color. We're looking at these 2 degrees. So it's going to be a negative 90 minus 0, so it's 90 right here. We have no slope here, so it's going to be a negative 45 minus 0. This is going to be a negative 45 here. And then we have a negative 90 minus a negative 90. So it's going to be like negative 90 plus 90. So this is going to be a slope of 0. And so our Bode diagram is going to look like this color. And so from this, we can write this out. We can see that 0, we have a 0 degrees for when our omega is less than or equal to our 5. So we're going to have a 5 right here. And then the next one, we have negative 45 when omega is what? Well, we know that inside of here, our omega, and this is actually going to be our omega c, is equal to 50. So we found our omega c as well. We can write this in here as 50 rads per second. And then we're going to write this in here as well. For this negative 90, we know that omega has to be greater than or equal to this 500. So we're going to write a 500 inside of here. And so that is how we would fill out the table for this problem, and that's how we would go about solving it. If you want more problems like this, they're in the playlist, link below the like button, and if you have any questions, feel free to leave them in the comments below about this material.